All right, so I need to give you guys quick inverse trig functions, which I think you already probably somewhat know, maybe? Okay, so first, let's remember just inverse functions in general. Good. There's a little -1 in an exponent. Yeah. So if I had a function f of x, right, I would think about that as something that takes inputs to outputs, right? You guys remember what's important for f to be a function? It has to be a rule associating inputs to outputs. No.
Vertical line test. Oh, yeah.
Yeah, the vertical line test has to be passed. So a function, right, for a graph to be a function, it has to be vertical line testable, which means that each input goes to
one or more
one and only one output. So let's remember function. How about that? So associates inputs to outputs, and each input associated to one, meaning the rule acts on its inputs, right? And only one output. And the
You could give nil outputs.
output. No, these functions don't do nils. So if something does nil outputs, like it says, yeah, that's not allowed, that means that the input wasn't in the domain of the function. Because that computer programs do this like, whoops, nil input thing. And what they mean is you went outside the domain. Cool? So those aren't actually inputs. They're just things you tried to input, but they weren't actually inputs. It's cool with that? So those are things that are like,
That just went, yeah.
right, they're like outside the blob. It's cool with that? Can you give me an example of something like that?
You're trying to determine this. Your calc says error.
Yeah, your calculator says error. When does your calculator say error?
Divide by 0.
Yeah, so when you try to divide by 0 or take the square root of a negative number, or when you try to feed something into an inverse trig function that shouldn't go in, right? So there's a bunch of reasons for this. Or when you try to log something that's
Negative.
negative or 0. You guys see that? So those are things that are outside the domains. And now I think we need to remember that this thing here, right, about inputs being associated to one and only one output, that's the thing that Oven started with, which is the vertical line test. Okay? This guy? Vertical line test. You guys all remember how that thing works?
Draw a vertical line top.
Yeah, so if you have a graph that might be a function, you kind of run vertical lines across it. If it hits twice, for any vertical line, it fails. So like, for instance, my bubble diagram up here is definitely not a function because this vertical line, for instance, strikes twice. You guys see that? Okay, so that's functions and vertical line tests. Now, what am I talking about? Inverse functions.
So you're taking outputs and finding inputs.
Good, yeah. An inverse function does this way, right? And so that would be labeled f inverse of x, assuming that the thing exists. And I want you to draw from this, these don't always exist. You guys see that? Like, some of the rules just might not have unrules that are functions. You guys know an example of a function that doesn't have an unrule?
Sine, square root,
Yeah. Sine doesn't have one.
square root.
Square root isn't an unfunction for squaring. How about that? You guys see that? square root and squaring get complicated, right?
Mhm.
Why?
Plus or minus.
Yeah, there's a plus or minus, right? There's inputs that give you the same output.
Isn't it just a user error though, is because of the plus or minus? Like, cause
No, that thing's not a function.
Okay.
You need to remember those things and you need to be careful. So a lot of the user errors in Algebra 1 and 2 are caused by students thinking that something is an inverse function when it's just kind of an inverse idea.
Okay.
You guys see that? Does that kind of make sense? Maybe not. So squaring and square rooting seem like they ought to undo one another, but they don't. Cool. So what am I looking for an inverse function? So I'm going to just call functions that have inverses, I'm going to call them invertible. Okay. So for a function to be invertible, it's going to be a function, right? So it's going to associate inputs to outputs. Outputs. And it's also going to have the each input associated to one and only one output. Right? You guys see that? So it's a function. It has those two things the same as the function. That would be this thing and this thing. So we got those two things. What do we need to add to this?
The inverse is function, the inverse is inputs are associated with the original function's outputs.
Yeah, you guys see that? So an invertible function, right, is going to have an inverse that's also a function. So that unrule needs to take outputs over here to inputs over there. And that's going to happen when each output of your original function is associated to only one input. You guys see that? So that's going to be a little bit like running this condition backwards. So each output is associated, can't spell today, associated to only one input. That's cool, that? In other words, right, an input over here goes to an output over here, and that's the only way to get there. Let's call this. Do you remember the line test for that one?
Horizontal.
Yeah, good. This is, so this piece here is where the horizontal line test came from. Cool. Do you guys remember the relationship between the graphs? So if you have, let me kill a little space here. Hold this up against something white. So if you have, for instance, oh, I don't know, what's our favorite function? So if you have, for instance, your favorite function, which is like cubing, okay? How do you get the inverse function out of this? Graph for the inverse function?
Yeah, flip it
Flip
across
it.
the line like that. No.
Let's see, so
Horizontal flip.
this is the x and that's the y, right?
X, Y.
So I need to flip the
Oh, X,
inputs and the outputs, right? You guys see that? Yeah, so I might remember from Algebra 2. Dear God. I might remember from Algebra 2 that I should grab the corners
And flip them kind
and flip this way.
yeah.
You broke the corner a little.
Yeah, sad face. Need tougher plexiglass. You guys cool with that? So remember the trick for getting graphs? You can flip over the line y equals x. Cool? Good on regular inverse function review?
Yeah.
Okay.
Mhm.